Hey guys, so I thought I'd just make a quick video on binomial expansion because it's kind of a confusing topic. So we're going to start working with Pascal numbers, which is the first thing on the worksheet. So we're going to start with just the basic form, which is nk, just to get a basic definition of how to find any Pascal number. So basically you're just going to do n factorial over k factorial times n minus k factorial. And then that's just the basic thing that you're going to find. So we're working with an example. We're going to do 7, 3, and you're just going to do 7 factorial over 3 factorial, just plugging the values. N would be 7 and k would be 3, times 7 minus 3 factorial, which you're going to get 7 factorial over 3 factorial times 4 factorial. And the key for simplifying this is finding terms that cancel out. So you can do 7 times 6 times 5 times 4 factorial. Make sure you keep the factorial in there. And then you can do 3 times 2 times 1 to simplify the 3 factorial times 4 factorial. And then you see that the 4 factorials cancel out. And this becomes 6, so this cancels out with the 6 on top. And you're left with the 7 and the 5, which becomes 35. So the answer to the Pascal number of 7, 3 would be 35. Okay, working with another example, we're going to go 8 and 0, which is going to become 8 factorial over 0 factorial times 8 minus 0 factorial. And the thing to remember with this is that 0 factorial becomes 1, not 0, so it's not undefined, it's just 1. And then it becomes 8 factorial over 8 factorial, cancel out, which equals 1. And then similarly, if we have 8 and 8, we get 8 factorial over 8 factorial times 8 factorial over 8 factorial times 8 minus 8 factorial, which equals 8 factorial over 8 factorial 0 factorial. And remember, the 8 factorials cancel out and the 0 factorial becomes 1, so you're just going to get 1. So ultimately, the 8 and the 0 and the 8 and the 8 are both going to become 1. And this is a common thing for all Pascal numbers with either the 0 on the bottom or the two numbers that are the same on the bottom and the top. Moving on to our last example of Pascal numbers, we get 8, 1, which becomes 8 factorial over 1 factorial times 8 minus 1 factorial, which equals 8 factorial over 1 times 7 factorial. Now when we simplify this, we get 8 times 7 factorial over 7 factorial. Those cancel out, you get 8. So whenever you have a 1 on the bottom, you're always going to get your number on the top. So for example, if we had 7, 1, then we're going to get 7. And if we had 6, 1, then we're going to get 6. So just review those rules at the bottom, which we already discussed, and you'll be good with Pascal numbers. Moving on to binomial expansion, which obviously is a little bit more complicated. You're going to use the Pascal numbers a lot. So for example, if we have x minus y to the third, you can see it expanded out on your sheet, so we're going to use binomial expansion. So first, you're going to start with the 0th term. So you have 3, 0, and you're going to raise x to the 3 minus whatever the bottom term is. So you're going to raise x to the third, and you're going to raise y to the whatever the bottom term is. So you're going to raise y to the 0 in this case. And then because there's a minus sign here, you're going to alternate every time. So we're going to put a minus sign here, and now we're going to do 3, 1. And then we're going to do x, and because now it's 3 minus 1, we're going to have x squared, and then because the 1's here, it's going to be y to the 1. And then we're going to put a plus because, again, we're alternating each time. And then we get 3, 2, and 3 minus 2 is 1, so we get x to the 1, and we get y squared because that's the bottom term. And then we're going to get minus because we're still alternating, and we get 3, 3, not a ton of room here. We get x to the 0 because 3 minus 3 is 0, and then y cubed. And so when we simplify that, we get that 3 factorial over 0 factorial times 3 factorial becomes 1, remember. So we just get times x cubed times 1 because y becomes 1. And then we get minus, and then whenever we have a 3 and a 1, we just get the original number. So we do 3x squared y plus, and then whenever we have the 3, 2, we're going to discuss this more later, but these two are actually the same. So we're going to get 3xy squared. Then we're going to do minus, and remember whenever we have the same term on the top and the bottom, it just cancels out to become 1. So then we get x to the 0 is also 1, so we just get minus y cubed. And so basically this simplifies to become x cubed minus 3x squared y plus 3xy squared minus y cubed, which you can see is the same as on your paper. Okay, and moving on to our last example of binomial expansion, we're only going to do the setup for this one because this one's a little longer. But we have 2x squared minus 3y to the 4th. So there are going to be 5 terms in this, which is good to remember because you start with the 0. So you start with 4, 0, and you go up to 4, 4. So that's 5 terms. So I'm just going to write that at the top, 5 terms. So your first term is going to be 2x squared raised to the 4 minus 0, which is 4, times 3y raised to the 0. And then we're still alternating because it's a minus sign. So we're going to do minus 4, 1, and then we're going to do 2x squared, and 4 minus 1 is 3, so we're going to do the third, times 3y to the 1 because the bottom term is 1. And then remember we're still alternating, so then we get a plus sign. And we get 4, 2, times 2x squared to the 4 minus 2, which is 2, times 3y, still to the bottom, so it's just to the 2. We're running out of room here, so we're going to go to the next line, minus 4, 3, times 2x squared to the 4 minus 3, which is 1, times 3y to the third, because we're doing the bottom term, and then the last term is plus 4, 4, times 2x squared to the 0 times 3y to the 4th. So that's how we're going to set up this one. We're not actually going to expand it because that's going to take a little too long, and oftentimes you're just going to have to show the setup and not actually expand it. So don't worry about doing that. Moving on to finding specific terms of a binomial. The example here says find the 8th term of the binomial 5x minus 2y to the 12th. So if we find the 8th term, remember the 8th term is actually in the Pascal number. It's actually in the 7 because we start with 0. So we have 0, 1, 2, 3, 4, 5, 6, 7, which is still 8 terms, right? So then we have 12, 7, and then remember we're just using our rules from earlier. So we have 5x, and then we do it to the 12 minus 7, times negative 2y to the 7th, because we still do the bottom term. So now we can see if it's negative or positive based on this negative 2y. So if we simplify out 12, 7, we get, hold on one second, we get 12 factorial over 7 factorial times 12 minus 7 factorial, which equals 12 factorial over 7 factorial times 5 factorial. And then we have 5x to the 5th times negative 2y to the 7th. So when we simplify that, I'm just going to put it on my calculator. We get 792 times 3,125x to the 5th times negative 128y to the 7th. And remember that you're distributing the 5 to the 5 and the x, and the 7 to the 2 and the y. So that's how we're getting these. And then when we multiply them, we get a very big number, 316812312. x to the 5th, y to the 7th, and remember we still have this negative that needs to carry there, so we have negative that. So that is how you find the 8th term of this binomial. Okay, moving on to finding what term contains specific x and y values. Find the term with x to the 10th in the binomial 3x squared plus y to the 11th. So to find the term with x10, I like to write it out. So I like to do 3x squared to the what is going to make it to x to the 10th. And then I know that y is going to need to be something to make this equal 11. So I know that to get x to the 10th, I have to raise this to the 5th power because we multiply and then we get x to the 10th. And I know that because 5 plus something has to equal 11, this has to be raised to the 6th power. And as we reviewed earlier, to find what's in here, we have 11 terms total, and then we use whatever over the second value. So we have 11, 6, and so now we have 11, 6 times 3 to the 5th is 243, x to the 10th times y to the 6th, and if we use our calculator, or you can solve by hand too, if you find the Pascal number, you get 462 times 243x to the 10th times y to the 6th. So you get 121,506 x to the 10th, y to the 6th. And hold on, 3 to the 5th, yep, times 462. Yes, and then this is your term, and you know that this is the 6 at the bottom, but that means that it's the 7th term actually, because remember that we have to put one less than the actual term number on here, so we know that it's the 7th term. And then lastly, finding constants in binomial expansion. The definition in here says a constant is an integer value with no variables in it. They are found by finding the point in which the variables cancel each other out. So for example, if you have x squared, and then you have times 1 over x squared, those terms, when they multiply, they're going to cancel out, and you get x squared over x squared, which is going to equal 1. So we're trying to find the point in which the terms cancel out. So in this example, it says find the constant x to the 4th plus 3 over x to the 6th to the 5th. So we have x to the 4th plus 3 over x to the 6th raised to the 5th power. And we're going to need to find the point in which these two terms cancel out. So just looking at it, I'm seeing that a common multiple is 24. So I know that if I raise, actually an easier common multiple would probably be 12. So if I raise this to the 3rd and I raise this to the 2nd, I find that these two terms added together equal 5. So you know that this works out. And you know that x to the 12th plus 3 over x to the 6th, or not plus, times 3 over x to the 6th raised to the 2 is going to equal x to the 12th times 9 over x to the 12th, which is just going to cancel out to equal 9. And so we can see that the constant in this is going to be this, and then we know that we have to have a Pascal number here. So since it's raised all to the 5th, then we have a 5 up top, and again we put the bottom in, we put here whatever raised to the 2nd value that we're using, so we use 2, and the Pascal number for 5 and 2 happens to be 10, so we multiply this by 10, multiply this by 10, and this is going to equal 90. Okay, so just a little recap of what we've done so far. When we have a Pascal number and when we have binomial expansion, we have n and k, and we're raising the first term in the binomial expansion to the n minus k, and we're raising the second term in the binomial expansion just to the k. And so when you add these two together, they should equal n, which is the top term. So n minus k plus k equals n, which works. And so that's a simple explanation of binomial expansion, Pascal numbers, and finding terms and constants of binomial expansion. I hope that helped.